Okay, I need you on page 29. Yesterday, we looked at how to tell if a graph is proportional. What are the two things you got to look for if a graph is proportional? Yes. Good. So, if a line is straight and it goes to the origin, and it has to be an and. Those two things have to happen. Okay. So, now, do I give you a graph? No, I give you a table, right? So, we have to determine if the following ratios are proportional. Okay, number one, the following are times in minutes and the number of problems Chris solved during the week. Yes. Yeah, this table is the same thing as a table written like this, right? But now I'm going to show you from a table how to determine if it's proportional. Yesterday, I taught you from a graph. So if I gave you a graph, I didn't show you how to do it from a table, sort of. I showed you how to graph. Today, hey, there's no graph. You got to determine if it's proportional from a table. Just a table. It's pretty easy. Let me show you. Okay, you have to go y over x. Remember, y goes on top, x goes on the bottom. I should see you writing it down right there. So, if I give 3 minutes to Chris, he can solve 9 problems. If I give him 2 minutes, he solves 4. If I give him 4 minutes, he solves 16. If I only give him 1 minute, he can only solve 1 problem. Is that proportional? So we're going to write all of these y over x. 9 over 3, 4 over 2, 16 over 4, and 1 over 1. Are they the same ratio? Well, right now they don't look alike because they don't have the same numbers. So what we have to do is we have to simplify. Yeah, divide. What do you divide 9 and 3 by? Good. Write it down. What do you get? 3 over 1. Put a box around it. What do I divide 4 and 2 by? What do you get? 16 and 4. What do you divide by? And what do you get? In your box it in. 1 over 1. Can I simplify that? So what? No. It's a ratio. Ratio needs 2 numbers. So you're done. Do these match? How do they match? Okay, do they match completely? No, they have to match completely. So, do they match? No. So, are these ratios proportional to each other? No. If they did match, then it would be a proportion. If I graph these, it wouldn't be a straight line, basically. All right, number 2. The following are cups needed to make the color green. If I have 5 cups of blue, I need 2 cups of yellow. If I have 15 cups of blue, I need 6 cups of yellow, and so on. So, what's my first fraction? What do I write on top? Good. Order matters. Then it would be good. Good. Okay, now we have to simplify. You can use a multiplication table to simplify. What can I divide 2 and 5 by? Nothing. So we're going to put a box around that. That means it's completely simplified. You can't do anything with it. 6 and 15. What can I divide by? Good. Show me. Good. Box it in. Hey, do they match? Yeah, okay, let's keep going. Everything has to match. Good. What does that equal? Good. So far, so good. Let's see if the last one matches. They do? Nice. So, is it a proportional relationship? Yes. So guess what? Now I'm going to treat you like I did my honors kids. And I'm going to say, you know what? What's the unit rate? Two-fifths. What would be the decimal of 2/5? Okay, because you were telling me that 1/2 is 1.2. Thank you. I'm just trying to make sure that we don't do this, right? And that's wrong. Just to make it clear. Okay. Okay. My equation. Here's how I don't know if I told you guys before. Would be my equation. Oops, I forgot the one. Yeah, I told you that? Because you've been used to writing it like this, right? Guess what? Do the same thing. Okay? So, you can see it written like this. Now, this is a lot harder, right? But they're equal to each other. So please don't make this mistake. Alright. Number 3. Mary kept track of the amount of text she sent in a given time. So, in 6 minutes, she wrote 18. In 9 minutes, she wrote 21. In 5 minutes, she wrote 20. And in 24 minutes, she wrote 30. With no response from her mom. Okay. Write out the ratios in fraction form. So write out the ratios in fraction form. So you should have written 18 over 6, 21 over 9, 20 over 5, 30 over 24. What do I divide 6 and 18 by? Okay, I know it's 6. I'm going to use 3 just to prove a point. Okay? So if I do 3, I get 6 over 2. Am I done? No, I can divide by 2 and we get 3 over 1. Now I'm done. I can box it in. So even if you choose a smaller number to divide by, you're just going to have to do it more than once, which is fine. 21 and 9, what do I divide by? 3, and I get? Okay. You can stop right there. As long as 2 don't match, that's it. There's no way to fix it, right? So you can say no. Now you can continue, but as soon as 2 of them don't match, you're done. When they do match, you have to do all of them to make sure all of them match. Because sometimes the last one is the one that tricks you. Alright, go for it. The next one. I baked several cupcakes with different thicknesses. I kept track of how long each cupcake took to bake. And you know I'm not going to fix it, right? Okay. So if it's 4 inches, it's going to take 8 minutes. If it's 16 inches, it's going to take 32. So go ahead and write the fractions underneath. That's your first step, always. Yes or no? Okay, so because it is a yes, that means, what do they all equal? 2 over 1, right? I'm not showing a lot of work because I kind of expect you to know how to do this now. What is my unit rate? What is my unit rate? We can just say 2. Because what's 2 divided by 1? 2. What is my equation? Easy? Oh no! If I turn the page, the tables are now going vertical. Is it the same thing? Yeah, as long as you know which one's y and which one's x, because you have to write it y over x. So here I'm going to go 4 over 6, 6 over 9, 8 over 12, and 3 over 2. Simplify. Ooh. It's like nothing happened. All right, simplify that. All right. Number 5. Is it a yes or a no? Okay. If I divide this by 2, I get 2 over 3. Box that in. If I divide this by 3, I get 2 over 3. If I divide this by what? 4, I get 2 over 3. So if you said no, which one did you not divide correctly? So this is a yes. So therefore, boys and girls, what is my unit rate? 2 over 3. That's it. What is my equation? Yeah. And sometimes you just want to leave it as a fraction. You don't want to turn it into a decimal. Sometimes. All right. The last one. Do it. 8 over 1, 16 over 2, 27 over 3, 36 over 4, 40 over 5. So you wrote them y over x. Then you simplify. Can I simplify 8 and 1? Nope. So you box it in. You're done simplifying. 16 and 2. What can I divide 16 and 2 by? By 2. And you get 8 over 1. Hey, they match. Can I stop there? No. I got to keep going. 27 and 3. What do I divide by? What do you get? Oh, no. Do they match? You can stop there. Even the next one's 9 over 1. And this one, if I divide by 5, 8 over 1. So 3 of them match. Is it a yes? No, they all have to match. Got it? All right, the last thing I want you to do is to graph the ratios from number 1 below and graph the ratios from number 5 below. So you can open up your packet and you can see the ordered pairs for number 1. What's my first ordered pair for number 1? Oh, okay, yeah, 1, 1, or 3, 9, 2, 4, and then 1, 1. Can I graph 4, 16? Nope, so you just graph the 3 that you actually can. I got these numbers from here, from the first table. Okay, so 3, 9, 2, 6, 1, 1. So go ahead and graph those points on your graph, please. Graph them. Connect using a ruler. Okay, I'm done graphing number 1. What do you notice after you graph the point. It's not a straight line, and it doesn't start at the origin, right? So is this a proportional graph? No. So this is non-proportional. Why? Because it is not a straight line, and it does not start at the origin. Kimberly, write this down, please. All right, what about number 5? These are your ordered pairs for number 5. 6, 4, 9, 6, 12, 8, 3, 2. So graph these points. So 6, 4, 9, 6. I can't do 12. 3, 2. Then you graph it. Are we done graphing it? Okay, what do you notice from this graph? Straight line, and it starts at the origin, so that means it's proportional. Because starts at the origin and it is a straight line. Any questions?